This is episode 11, and in this episode we are going to be looking at arrays. So arrays are essentially a fixed collection of elements of uniform type, accessible by their indices. So oftentimes you may realize that you actually need to make use of a collection or a group of elements that are of the same type. And the best way to manipulate such elements is to store them inside of an array, and then you can always make use of the array to manipulate or work with the elements. So the important thing with arrays is that you have a collection of elements that have a single identifier, but you actually have them multiple instances of the same element, or rather of the same identifier, as it were. Just to explain the concept of arrays, maybe let's go ahead. Actually, before we go ahead and do that, let's just finish the points right here on the comments. So most programming languages use zero-based indexing. So we'll be looking at that in a minute. It can either use, so this is to say that you can either use 0 or 1 for indexing. Then box or square brackets indicate array indices, and arrays can either be 2D or 1D. Now with arrays, what you're doing is that you have this is the best way to visualize an array. So this, what you have going on right here, is a one-dimensional array, right? So essentially the dimension is going horizontally like this. So this entire row is our array, and this is an array of integers. It is an array of 3 integers. So we have 13, 55, and 78. So now maybe we could call this array with a single identifier, something like maybe say scores, is it? So this would be an array of scores. So now to access a particular element inside of this array, what we need to do, if you come back here, you realize that we said box or square brackets indicate array indices. So for this particular instance, this scores array, for us to access this element 13 right here, we actually have to make use of the index. So remember earlier on we said that you can either use zero-based indexing, meaning to say that your first element, like in this particular instance 13, the index position for 13 would actually be 0. So just to drive the point, explain the point further, if I wanted to access 13 right here, the way I would go about it is to make use of the index that is 0 there. Or if I'm using zero-based indexing, or if I'm using the convention that is typically used for pseudocode, is just to make use of 1 for ease of use. So if you are going to use zero-based indexing, you need to remember that your elements are always going to be n-1 for their index positions. But otherwise, if you're just using the conventional indexing, you know that if you have 3 elements, then the indexing is also going to be the same for each. Then, so this is an example of a 1D array. So let's actually go ahead and declare this array right here. So the identifier for our array, we said we wanted to call it scores rather. Then it's going to have 3 elements. So remember we said that we can use the convention for pseudocode. Instead of using zero-based indexing, we can just use the convention. That is to say, for 3 elements, we can just say we are starting from index position 1 up to index position 3. So essentially, this is going to declare or create something like this rectangle that you are seeing right here with 3 slots in it. So to actually assign these values inside of the array, what we can do is we need to make use of the subscripts or the indexes, as it were. So we know that in scores 1 we have a value of it should be 13, I think. It's 13. So the way we can store 13 inside of that particular position or in that particular slot is to make use of that the one subscript there. Then for the other 2, the way we go about it is to make use of the subscripts again, or the indexes, as it were. I think we have 78 here in the second slot. Then we should have 55 in the final state. Actually, it's the other way around. 25 goes here, then 78 is here. So this would be an array of integers, and this is the way you would assign values to arrays. Now it's important to realize that you cannot assign arrays a value in one go. So what we are saying is this. Let me just put a comment right here. This is not allowed. So let's say you wanted to assign all the scores inside of your array a value of 0, and you would think to do something like this, right? So you're saying this is illegal. You cannot do this. So later on, when we look at how to iterate through your pseudocode, you'd actually see that there's the way that you can assign values to array indexes or to array elements is to make use of a loop, but we'll be talking about that in detail. But otherwise, this is how you can work with 1D array declaration, that is on line 6. Then this is how you can actually assign values to your 1D array. Then we also have another type of array called a 2D array. Now a 2D array, it's more like a grid, as it were. So you'd realize that we have, let me just put the subscripts right here so that they run in parallel. So 1, 2, 3, and 4. Then 1, 2, and 3 right here. So just like with the 1D array, the way we count the dimension is to count the rows first, then the columns. So for this particular instance, we have this array of integers with 4 rows and 3 columns. So to access a particular element inside of a 2D array, now we actually need the horizontal as well as the vertical index. So for instance, if we wanted to identify 17, the way we go about it is to, maybe let's call this one max, right? This one is called max. So if you wanted to obtain that 78 mark right there, the way you go about it is actually make use of the row, then the column. So it would actually be max 3 right here, then the column which is 2. Right, so remember I said that we're just using the easy convention. Zero-based indexing it's quite confusing for beginners, so that's why I'm just using the normal convention here for pseudocode. So max 3 and 2 will give us what? 78. Then let's look at how you can actually declare a 2D array right here. So 2D array declaration. So just as before, we go with declare array, then this one we said it's going to be called max. Then the dimension is, we know that we have 4 rows, so it's going to be from 1 to 4. So the way you separate the indices for the rows and the columns is to make use of a comma. So 1 and 4 are the lower and upper bound for the rows. Then 1 and 3 are the lower and upper bound for the columns, as it were. So this is how you would actually declare a 2D array. Then coming back to this example, we want to assign the element that is at position 3 to a value of 78. So remember we said that you actually need 2 indices to access a particular element. So if we wanted to assign a value of 78 to element 32, this is how we go about it. We would need the row as well as the column count for the element that we would want to assign in that particular instance. So this is the essence of 2D arrays, and this is how you can actually visualize a 2D array for pseudocode, in pseudocode rather. Then what's also important to realize with arrays is that we did talk about how you assign, we did talk about the dimensions, or rather the subscripts that you make use of the index values to access elements of an array. And we did also mention that you can actually use a loop to assign values to an array, and we did see that this is not allowed. Rather it's illegal. You cannot assign array elements like this. You actually need to make use of the subscript. So yeah, I think that's just about it for this episode. Again, remember we said that we'll be looking at how you can iterate through an array. Once we've covered iteration, I think with iteration at around episode 21, we will revisit arrays. This time around we'll be armed with our knowledge of iteration, so you can actually look at how you can iterate through elements inside of an array. But yeah, that's just about it for this episode. I'll see you in the next one.